Okay, so this is section 1.5, and in this section we want to talk about exponents and radicals. So basically we're just trying to understand a few more exponent rules and how those are related to a radical or a root, like a square root. That's a version of a radical. Okay, so here are some properties or exponent rules. I don't expect you to remember what they are called, but you do need to know what they are and just be able to identify it when you see it. Not necessarily name it, but just be able to recognize what you're looking at. I've already talked about A, C, and F in section 1.2, so I'm not going to go over those, but I do want to go over the rest of these. So B says that if I have the same base, again, we have to deal with the same base. So if I take a to the m divided by a to the n, then I subtract the exponent. So like with a, when we are multiplying, we add. When we are dividing, we subtract. So just as an example, if I had 6 to the 5th over 6 squared, then that would leave me with 6 to the 3rd because of 5 minus 2 being 3. All right, and talking about D, property D or rule D, if I have two things that are being multiplied together inside of the parentheses, so they're both being raised to the power, then all I have to do is raise each one of those to the power. So let's say I had 7x and that whole quantity is being squared, then I can just say, well, that's 7 squared times x squared. 7 squared is 49. So that's 49x squared. So that's just an example of property D. Now property E, similar to when we have multiplication inside the parentheses, if we have division, it works the same way. So we are just, we take both components inside the parentheses and raise it to the power. So if I have 1 over 3 to the 4th, then that is the same thing as saying 1 to the 4th divided by 3 to the 4th. 1 to the 4th is 1. 3 to the 4th is 81. So that's the same thing as saying 1 divided by 81. All right, and then property G here with a negative exponent. So a negative exponent, all it does is it shoots the base to the denominator of a fraction. Okay, so as an example, let's say that we have 5 to the negative 2. Then I am saying that is 1 over 5 squared, which is then 1 over 25. Okay, so that would be the negative exponent. And then we have this last one. So anytime that we are negative, we're flipping it. So it works the same as G, but if we had something in the numerator and the denominator, so like we had 1 over 8 to the negative 2, then that's the same thing as saying 8 over 1 to the positive 2. Now it works the same as rule E with our quotient that's being raised to a power or a fraction. So I take both of these components, 8 squared and 1 squared is just a final result of 64. So those are the basis of the exponent rules and just how they're used. And we'll use these to simplify expressions as we go on. Okay, and so now we do want to talk about radicals and just how they're related to exponents. So for all rational numbers, m and n, so basically we can create a fraction. Then a to the m divided by n is equal to the nth root of a to the m. Okay, so I know that I just said a lot, but I just want to give you an example. So let's say that we had 5 to the 3/2 power, then that's the same thing as saying the square root of 5 being raised to the 3rd power, which is the square root of 125. Okay, so the top number, my m, so to speak, is what is going to stay in the power as a base. And then my denominator of my power is what becomes the root. So let's say like we have 2 to the 1/3 power, then that would be the 3rd root, or the cube root, of 2 that's raised to the 1st power, and 2 to the 1st power is just 2. And this actually concludes our section 1.5 video. So if you have any questions, please feel free to email me, and have a great rest of your day.